do you have anything to discuss?
No, I'm not at the moment. I'm fine.
All right. So I have a note from last time that we should look at atoms before calls, and I guess we were doing call documentation before, and yeah, so we haven't started documenting atoms yet.
Okay.
So let's try that. Or was that this first easy sections branch that I have from a long time ago? So that one. Did touch on atoms. Okay, so let's let me rebase that. And there's a conflict. And the conflict consists of this. Marking up the F string. That's the correct way to do things, but oh, I see what happened. My earlier commit removed this and moved it to the end. So we need to mark things up here as well. And that should be it for the conflict. And now there's a new conflict on the parser. So the solution for that would be to regenerate the parser. That's a regen. Continue, and we're wherever we started. So I'll make a diff to the main branch just to see where we were. So this is mostly in expressions. Sorry, someone's calling me. I need to take it. I'll be right back.
Yeah, no problem.
Hallå, Noriden? Ahoj, ja. Jsou v republice, ale jsou teďka zrovna na mítinku. Šlo by... No, můžeš, pojdej. Jo, děkuju. Jo. Right, sorry for the delay. I am back now.
That's fine.
Alright, so, I think it's best to rebuild the documentation so we see the new version we want here. And that would be better syntax notes here.
Okay, yeah.
Maybe we should even move this to the introduction.
Oh, you mean like because it applies to the whole section?
Right.
Yeah.
But, well. Now this and the following chapters. Should we add this to all the following chapters first of all?
Oh, right, because people might land in a following chapter and not see that part.
Yeah.
Yeah, it does sort of assume that people are reading it in a strict sequence.
And is this true for all the following chapters as well? Like when you have an alternative like that and no semantics are given, then the semantics are the same as for the single name here. I guess that's kind of obvious. But yeah, it does it does apply here, right? This just gives some semantics, and it's so this doesn't give any semantics, and it means that, you know, if it's a return statement, then the simple statement has the same meaning as this returns. Kind of makes sense. On the other hand, we're moving to the scheme where the formal syntax isn't the first thing you find. So I think we should always explain this. What was here before?
Did it used to be different? In other words, that's always been the case, right? That's not a new...
So the current docs say when one alternative of a syntax has the form name other name and no semantics are given, blah blah blah. So there's this parenthesized one alternative of. I don't know, maybe this is even better than what we came up with before. It's kind of, I mean, it's kind of unclear what this form means, right?
Yeah.
Maybe we should go back to this and try to make it clear. So when one alternative of a syntax rule, so instead of has the form, let's explain this. How do you call name? So that's a reference to another rule. Is this more obvious? And I guess we can move this to the introduction too. Am I making this better?
Yeah, that's.
And this should
Right.
probably have text first.
For example, right. Beautiful.
Let's see, it's just A and B. Do we have an example of a rule without alternatives?
Yeah, there you go.
There we go. Hopefully we won't have to change this. No, but this one has semantics given, so it's not the same. It would be the same if it was just this. Do we have an example somewhere here? The lower bound, upper bound, it's tried.
Well, where it says slicing, it says primary slice list. There's no alternative there.
Right, but it's not just a single reference to a rule.
Oh, I see. Okay. Yeah, then that would be better. Yeah.
So this would be a good example, but I think we got rid of that example in the previous pull request. It would be nice to have an example that actually occurs in the grammar.
Yes, of course. Yeah. Other than
On the other hand, we're going through this, and we'll probably end up
maybe if it
removing
doesn't
that
occur,
example.
then
oh yeah, if it doesn't occur,
then we're explaining it. You know, it might not be worth.
Do that. So this would be a nice example, but it's really big. This is kind of the same. Let's just use this. that make sense?
Let's see here. I think, yeah. This is only for reference to another rule. Okay, listen. Sure. Okay.
On the other hand, we're moving to the style where we explain things in words first and then give the formal grammar. And the words should explain the semantics before you get to the formal grammar. So there should never be a case where no semantics are given. It might be best to leave this note as it was and then remove it when we're done. As the way this is written out, it's a bit complicated, and it explains a thing that's kind of obvious.
Right.
Like, you know, if you see this and you haven't read the note, what would you think about it?
Exactly, yeah. There's a certain consistency to it. There's nothing surprising.
Right. Like, what are the semantics of simple statement? Well, it's not spelled out the way you'd see it in a math textbook, but it's obvious, right?
Yeah.
Alright, so the cure here is worse than the disease, and I'll move this back to what we had before. So the form. Okay, so that's a revert from where we were previously. Well, that's probably good. And then this goes on to implementation for built-in numeric types. Arithmetic conversions. When it I'd like to get rid of this, but right. So this moves the list to this section. So Python fully supports mixed arithmetic when a binary arithmetic operator has a bunch of different numeric type, the operand with narrowed rep is widened to that of the other. And this is runtime behavior, so it's in standard types documentation. If either argument is a complex or floating point number, the other is converted to floating point number. Is that right? Right, because you can do arithmetic on complex and floating points. Otherwise, both must be integers. I guess this only applies to built-in numeric types, so we should clarify that. Where was this? STD types. Library STD types.
Oh, it only applies to built-ins because otherwise you can make your own types?
Yeah, if you make your own types, you're on your own, right? Okay, so that's one thing moved. And then we get to the atoms. So atoms are the most basic elements of expressions. And yeah, forms and clothes in parentheses are atoms as well. And then we have the a to-do to remove the comma from start expression. So I'll move this to-do to my notes off screen.
Okay.
So this still the pull request or the changes we made earlier. So the first kind of atoms are built-in constants. This kind of contradicts the simplest atoms are identifiers or literals. Now they're keywords. Do those count as literals? True, false, and none?
Maybe not, because they can be spelled differently. Or do they always have to be capitalized?
Well, they do.
I guess they're yeah. I guess they are literals. I mean, they're quotes,
If we
right?
say the simplest atoms are names or literals,
Yeah. Yeah.
and maybe even link name to wherever we define that, that would be in the lexical analysis. Name. Now we can format this because it's all out of whack. Right, so built-in constants. The keywords transforms a non-name built-in constants, which is a link somewhere, apparently. Yeah, not implemented in ellipsis or not keywords. And what is this about special support in the parser? And the special support in the parser is all their keywords. Can we link to keyword? We can. That's here, right? It's just keywords. Good. So only the ones mentioned here are keywords. With special support in the parser. And have special support in the parser. Okay.
That looks good.
Then we have identifiers, names. So an identifier occurring as an atom is a name. See section on identifiers for lexical definition. Mangling for blah blah blah. Oh. Well, that sucks. Because we earlier defined names as both identifiers and keywords. And now we're saying that only identifiers occurring as an atom are names.
Oh.
The
Do we have to go
C-section.
back and deal with the keyword thing?
No, I think that's that's because there's a name token keywords are also initially tokenized as name tokens. Initially. Aren't they always? Yeah, they're always tokenized as name tokens. Now we should probably fix this documentation for token, for the token module. Keywords are always tokenized as the name token. I don't know if Python ever had tokens, like individual tokens for the keywords. You might look at, I don't know, the Python 2 docs. Nope. Let's try Python 2's tokenization. Python 2's tokenization.
Those are for operators, right? Those tokens?
Oh, keywords. If, true, and pass are all tokenized as name.
Oh, I see. That's right. Okay. I understand now. Okay.
Okay, so yeah, we can make that clarification. So a name is an identifier keyword. So in here, I think we should lean into the term variable. Let's see what the section naming and binding does. So names refer to objects. So this is interesting. If you read the Python documentation, like at this low level, you will not see the term variable.
Oh. Because I guess.
So so
yeah.
you have local variables, you have global variables, you have free variables and non-local variables and things like that. New variables in the global namespace, bound variables. But yeah, this this deals with the term name. Yeah, names refer to objects. wonder if we should. What should we do? Should we rename the name token?
I'm not really sure.
Or should we?
I mean, that's what it's called, right?
Yes, that is what it's called. But here the word name has a different meaning. Right? If we say in lexical analysis we say say what? Name tokens represent identifiers, keywords, and soft keywords. And I guess only in here we say that identifier is a name except keywords. Right, so name is like a superset of identifiers.
Right, right.
Here we say that an identifier occurring as an atom is a name.
Would it be useful to have like a little Venn diagram of like atoms, names, and identifiers?
Yes, but you need. So, for lexical analysis,
yeah, we don't have Venn diagram. Yeah,
name is a superset of identifier.
Right.
And then in the syntax, you have the identifier, which I guess this is the runtime semantics, the names. The names here. This is names refer to objects. Don't know what to do here.
Should we put like a
Should we
put a
rename
pin
the
in it
token?
and come back later?
Maybe. You rename the name token. But what should we rename it to?
noun?
Nah, a word. Word might
label?
be a good word for it.
For a word?
Because it's well, all the other tokens are white space or comments or texts, or most of them are symbols. Okay, this will definitely be its own pull request and discussion.
Yeah.
So I'll make a note in my off-screen to-do list, and let's leave this section as is, and go on to private name mangling. So when an identifier that actually occurs in a class definition begins with 2 more underscore characters and blah blah blah, it is considered a private name of that class. Private names are transformed to a longer form before code is generated for them. Transformation is independent of the syntactical context in which the identifier is used, but only the following identifiers are mangled. The name used as the name of a variable that is assigned or read, or any name of an attribute being accessed. This technically is in the wrong section, because attribute access, where do we have attribute access? In primaries. Right, so this shouldn't be in the items section. And I guess this makes it another candidate for a different pull request. So let's do that. And I'll remove the private name mangling from the work in progress. And let's go on to literals. So Python supports strings and byte literals and various numeric literals. Yeah, so we need to reword this. We need to get the formal syntax last. Let's say formally. string and byte literals and various numeric literals. So numeric literals are single tokens, right? I don't know if the various is a good word. Or should we say what literal is? Probably, right? Can we get a definition from like Wikipedia? A textual representation of a value. Defining this. Python supports numeric literals numeric string and bytes literals. Go, evaluation of the literal yields an object of the given type. String, bytes, integer, floating point complex with the given value. The value may be approximated. In the case of floating point and imaginary literals. Okay. So we need to tie this to the lexical analysis and say that numeric literals consist of a single number token. Can you do that? Yeah, I need to go Python grammar number token.
Okay, I think I'm back now.
Hello. Yeah, I'm trying to
Yeah, I'm back now.
word this. Welcome back. And we should refer to lexical analysis. What kind of example do we have for complex number? So they're syntactically expressions, but literals are also atoms which are kinds of expression. So we need to link to unary arithmetic and bitwise operators, which is a mouthful, right?
Yeah, it feels a little bit, I don't know, it sounds a little esoteric.
Right. So that's unary and the other one is binary. Wow. Such simple references here. Undefined label? What? Oh, right. Now this needs to be spelled out as class. I always forget that. Alright. So we are in literals. So that's arithmetic operations. How do you word this? You say expressions involving the plus or minus operator? Or we can say, or not literals, but unary or binary arithmetic operations.
Oh, okay. Yeah, that actually kind of. Yeah.
So, of course, the documentation is then unary arithmetic and bitwise operations, and then binary arithmetic operations, and then shifting operations, huh? which I guess is interesting. So if you do, if you call up the AST for something like -3,
Yeah.
yeah, you get the unary operation of subtraction, or negation in this case, and then 3. I wonder if the AST module has an optimization mode. No. Huh. Okay, so at the AST level, this will remain as is. But I know there's an optimization pass. I guess it's after the AST where this gets converted to -3.
Oh. Okay.
I guess we should say these are syntactically not literals. Oh, this is interesting. Oh, this is good. All literals correspond to immutable data types, hence the object's identity is less important than its value. Multiple valuations of literals with the same value may obtain the same object or a different object with the same value. Yeah, this needs to go after we say what the evaluation does. String bytes. This is a point. Literal section for this. So we have a number section in lexical analysis, and then we have string literals. String literals are more complicated because they have f strings and t strings. So we need to say string literals may consist of several tokens, and then we say C section see the section string concatenation for details. And I guess we need to say now that T-strings are also literals.
Oh, right.
So the types here will be infloat, complex, stir, bytes, or some kind of template. Where does the template come from? That's defined in in. That's documented somewhere. String template lib template. Okay. That's a mouthful. So all literals correspond to immutable data types. I guess we need to call out template strings here because those are not deeply immutable. Right, you can have T-string with a list in it and change that, right? Right, so the templates are shallowly immutable. Which I guess doesn't really, which I guess is really fine for this. Multiple evaluations of literals with the same value may obtain the same object or different object with the same value. So if I have one template like this and a second template like this, it could be that they are the same object. But CPython does not do this optimization right now. I wonder if we need to say something about that here. I don't know, what's the value for this template? That's somewhat complicated.
I haven't used template strings much at all, so I would say maybe something with maybe like a date variable or something.
A date variable. The list is
like
fine. You can change the value of the template of like whatever's in the interpolation
I see.
here. Is this still like correct?
So like maybe would you put in like something like the end of line or the beginning of the line, or
Okay, so you have some list, right?
Yes.
And
yes.
then you have a T string that references this list.
Yeah. Some list, yeah.
Right. So this says multiple evaluations of literals with the same value may obtain the same object or a different object with the same value. What's the value of this template? Right.
The value of the template is like the sum list.
So the value of this template is this template object.
Oh, I see what you're saying. Yes, okay. Is the template object. I see. Yeah.
And is it the same as this one? Or let's say we have other list, which for now is the same, and then we have
right.
other template, which is exactly the same,
I see what you
but
mean.
it references the other list. So this other template has this value. Is it the same value?
What does tokenizer say?
The tokenizer is not involved in here. The tokenizer is going crazy here.
Yeah.
Oh, the token. So that's interesting. So if we say now say sum list is 1, 2, and we say other template is sum list. So this is exactly the same as far as the tokenizer is concerned. But the template and the other template, I mean, they look the same, right? But they cannot be they cannot evaluate to the same object, because now if you do sum list dot append, they become different. A template refers to the value of sum list from here, And the other template refers to value of some list here, and only the other one changed.
I'm gonna make a note. I have to ponder this. Yeah.
Right. So here we could say that evaluations of template literals must result in distinct objects, but theoretically you could come up with an optimization that makes them the same, which would be fine. It's like the that would limit the implementation, right? So what do we do to be super correct here? I'd say for template strings, the value includes the identity of the objects, or the identity of the interpolation, the objects in the interpolation. What is that called?
The target, the source.
The value of the interpolation. The identity of the values in their interpolation. And I kind of want to make this a footnote. Or parenthesize it or something, because this is not really something you want to read here. It's just there to be,
Yeah.
just to make it, correct. Or let's say the identity of the values, their interpolations must match. alternative?
I don't have a strong opinion.
Nah, that's... Marking something as a node kind of highlights it. I mean,
It does.
want to put this in the fine print.
Too bad we don't have a fine print admonition.
Well, that's a footnote, right?
Yeah, I guess so. But the footnote is somewhere off in the distance, right?
Yeah.
It's in a different.
Or we can make this an implementation detail. I think this is
Oh, there you go.
Spell it. Yeah. And say C C Python each evaluation of a template string results in a different object. Identity of the values of note that for two template strings to have the same value, the identity of the values of their interpolations must match. This is still... There's a better wording for this, I know it.
Note here for later.
probably won't ever be an implementation of Python that takes advantage of this. I don't know. I'll probably need to sleep on this one. Let's go on in the time we have, and we'll go over it next time. So, string literal concatenation. We're referring to that here. So, multiple adjacent string or bytes literals to limit byte space, possibly using different quoting conventions. Allowed, and their meaning is the same as their concatenation. Okay, this feature is defined at the syntactical level, so it only works with literals. Right, I think we already did this earlier, given the example name here. Literal concatenation can freely mix raw strings, triple quota strings, and formatted string literals. Where bytes literals may only be combined with other bytes literals, not with string literals of any kind. Also, template literals may only be combined with other template string literals. Right. Okay, and this F string and T string are defined in lexical analysis, but they do refer back to expressions. Which is a bit confusing. But it's not really something we can deal with right here. And I don't know if you said anything in the past few minutes. Your avatar glowed green, so you were...
Can you hear me now?
Now I can hear you.
Oh, okay. Yeah, I'm having another little problem with my client. I changed. It seems like in the mobile, when I change windows, it doesn't refresh properly. But yes, I can hear you fine.
Okay. So this needs another pass. This is probably a good size of work for a pull request. So we skipped identifiers and private name mangling, and we have built-in constants, introduction sections, and the literals. We're leaving the parenthesized stuff for later. Parenthesized form. So we'll need to reword this entirely because the new grammar has tuple group and generator expression. Right, and we'll need to change this for the pull request unless we do tuple group and generator expression. What is group? Oh, we already did it. Yeah, well, I'm not looking forward to that. Right, so the work we did before continues with group and tuple instead of parenthesized form and so on. So we'll need to throw that away. To make the scope manageable. But I guess we can do that now. So let's see what we have here. So I have this in 2 commits. I have everything in a different branch, so I can freely mess around with this branch. So what I'll do is I'll rebase. And combine this to a single commit. Rewording of some of the atom section. And then I'll pick stuff that I want for this commit. I usually do that in a GUI, which lets me amend the last commit. And now I'll go through this. Basically go from the end, and I see that we have references to the mixed arithmetic. That can stay. That can stay. That can stay. Then we have this change to primaries. I'll remove that. Dig displays, remove that. Dig displays, set displays, list displays, parenthesized forms. Don't want to send that yet, and that means we'll have to change the formal syntax for atoms. Identifier literal enclosure, and this enclosure here that will need to stay. So yeah, we'll do that in the editor. Don't want this in token. I probably want to put this in the sample request. Right. I go here and I revert everything, so it's not in my actual files, and I have a cleaned up commit. Then I can go back to the atom grammar and throw out some of the changes there, just so we send the pull request. So previously we had identifier literal enclosure, that's these things, and enclosure here, and define the previous way. So that's parenthesized form, or a list display, or a dict display, or set display. Forms enclosed in parentheses, brackets or braces are also categorized syntactically as atoms, which means I can take this enclosure, I guess it's clear that that's what it means, and I can put it in the corresponding section. So literals, string literals, and here we have parent form. Now let's keep it here. We'll deal with that later. Again, if you're saying something, you're just blinking visually.
No, it's good. I'm agreeing. I'm following.
Right. Yeah, so as I said, this does need another pass, which I will need to sleep on. But I think we're getting closer to sending this part. And then we need to tackle the parenthesized forms, which I think they changed, or they're very different in the actual grammar currently. So there'll be much more untangling there. Does this look good?
Yeah.
Oh, and there's also the arithmetic conversions. The description of an arithmetic operator below uses the phrase the numeric arguments are converted to common real type. Do we actually use that phrase? It doesn't appear. Let's just look for part of that phrase. Slicing, which has nothing to do with it. And then the power operator says the numeric arguments are first converted to a common type, which links somewhere else now. Standard types. Right, and that means we can remove this section entirely. Alright, so arithmetic conversions. When a description of an arithmetic operator below uses blah blah blah, this means blah blah blah. There's some additional rules, and all of that should now be in this standard types section for conversion. Right. Does it also say some additional rules apply for certain operators and non-numeric operands? Extensions must define their own conversion behavior. Right. So I guess we can't really remove this section yet. We'll need to go through everything. Then we can get rid of it. Oh well. Well, I feel there wasn't a lot of progress this time, but hopefully it'll be better next time.
I don't know. I mean, yeah. We identified some hard things that need to be dealt with. So.
Yeah. Well, thanks for your attention. Put you here.
Oh, it's my pleasure.
Push it to my branch. And we'll continue next week.
Yes. Yes. Cheers.